Okay, so default arguments are a way to allow the omitting of some arguments. That is, the parameters are there, and when you call it, you can call it with fewer arguments than the number of parameters. So let's take an example, it'll make more sense. So default arguments allows us to omit some arguments, and the way we do this is we assign default values in the function definition. So, the function declaration, which can also be the function definition. So when you declare the function, the last argument, the last n-1, or the last, actually all of the arguments can have default values assigned. So this is saying that whenever this is called, if there is only one argument, then these other two ones will get their default values of 1. So for example, if you call this function with just one argument, then width and height are defaulted to 1. If you call it with 2 arguments, length will get whatever it's passed in, 3, width will get a 5, and height will default to 1. And if you call it with 3 arguments, then you don't use the default values. All the arguments are supplied. You can assign default values only to the last n, and so if you have 3 arguments, you have to either have default values for the last one or the last 2 ones, or all 3. You cannot have, for example, a default argument for length and then skip width, or you cannot skip width and height and assign a default value of length. Okay, so we'll take a look at that. Maybe that'll become clear. You want to go through that example. Let's take a look at a simple example. So you can use this in combination with overloading, but now you have to be careful. So for example, let's say you have one function with an int and double, another with int called by or passed by reference, and then another int, and then 3 ints, right? So you can say have this be a default of 1. That's fine. Now, so this is overloading. So this is overloading func, but notice you can call this func with 2 parameters. They are both ints, but you'll be confusing to the compiler because here this is also a possible match. And so now it'll give you an error message saying, if you try to call it with just 2 arguments, do you mean this one or this one? Okay, so either one is a possible match, and the compiler does not have enough information to decide. Alright, so this, once again, this error message comes about because the C++ compiler looks at these as overloaded functions. It's the same signature, sorry, they have different signatures, but it has the same, when you call it with 2 ints, this is a good match, and so is this, and so C++ compiler does not have enough information to decide which one you mean. Alright, so what do you have to do in that case? In this case, we have to use a different function name. That's one way of getting around this. Okay, and then you have to say specifically in here, if you call this with the func1, this is perfectly fine. X, the value of x, 100, will be put into here. Value of y, 200, will be put into here. Since we do not supply a value z inside this function will automatically be a 1. So it'll add 100 plus 200 plus 1. Okay. You can also do the same thing with this. And say the second argument is a 20, and then you can call this func1 with just 1 argument, and that'll work. And you call this, x will be a 100, it'll put 100 here. Since there is no y, it will have the value 20 in here, and since there is no z either, it'll have a value 1 in here. Alright, then you can also do this. You can say 1 and then call func1 without any arguments at all. And they will all take their default values. What you cannot do is omit 1. Oops, hit the wrong key. All right. So you cannot omit, for example, the middle one. That is, will that work? No, it'll give you an error message. In this case, it looks like, yeah, invalid arguments. So you cannot omit one. You cannot omit, well, you cannot. In this case, this won't work either. Yep. So you have to have, it's the last ones that are important because those are the ones that, for example, get omitted. Right, you can make sure this has a problem because, yeah, there's no match at all. So you have to, you have to have two values, X and Y, and that'll be fine. Okay. So you can also have that, for example, or a Z value, and you can have another parameter, a variable if you want, and the 4 will go into Z, whatever Y is will go into here, 200, and 100 will go into here. Okay, so there's a lot of ways to test and debug functions. One was the cout school of debugging, which is basically putting a lot of print statements in your code that you can do, but it's probably much better to use the debugger. This is dependent on the environment, and we have a nice debugger in Eclipse, and so don't have to worry about that. Another thing that we can do is use the assert macro. And assert, like in Java, if you'll have a Boolean condition. If that condition is true, then you go on and execute the rest of the code. In Java, we can enable assertions and disable them. They're by default. Remember that assertions are disabled. You have to enable them explicitly. We have a similar thing in C++. You can enable them or disable them. You can also use stubs and drivers to set up a test situation where some of the functions are not actually implemented. All you have is like a fake method that you call a mock method. Okay, so let's take a quick look at the assert macro. Assertion is a true or false statement, and what we want to say is that we assert that this condition is true. It doesn't return anything. It just evaluates this condition. If it's false, it just stops the program completely. It's a little bit different from Java. Java is a little bit cleaner in that asserts throw an assertion error, and you can catch that error. So that's the nice thing about Java. They spent more time thinking about this. In C++, it's a little bit more basic in the sense that if this condition is not satisfied and assertions are enabled, then it terminates the program. Okay, so this is used. Why do we use this? We use to check usually preconditions and postconditions. So we talked about preconditions very briefly. Those of you who have completed CSIS 235, that is object-oriented programming, you have seen this and you've used it. So for those of you who haven't, preconditions are conditions on the inputs of a method or a function. You want to say that these conditions are true of all of the inputs. And then typically what we say is if those conditions are all true, then we can guarantee some certain behavior, and those are called postconditions. So basically we say, for example, take the square root function. The precondition would be that the square root of, if you're going to do the square root of x is not negative. X has to be 0 or positive, right? And so then we say the postcondition is that, and here's the assumption, that if the preconditions are true, we guarantee that we will return something that if you square it, wait a minute, something that, yeah, if you square it, you will get the same thing as the input, essentially. Okay, so why do you use this? You're confirming that your inputs are valid, and if the inputs are valid, you're guaranteeing that the method or the function will do the right thing. And that's the guarantee is in the post condition. Okay, so the syntax is very simple. Assert looks like a function call, and you put in the condition. A little bit different from Java. In Java, you don't need the parentheses, although I still do like to put the parentheses when I'm using Java, just because it looks good to me. Okay, so Java, you did not need parentheses. C++, you do. This is pound included using the Csassert library. Okay, so here's a simple example. In this case, you have a function with 3 ints. First one is passed by value. The other 2 are passed by reference. Precondition is that the coin value, once again, I just want to quickly say that in Csis 235, we wanted real Boolean statements here, so this would not be a Boolean statement, and so you'd have to fix it up to meet the standards of the Csis 235 preconditions. And I think I'm explained in that course that a lot of programmers will use something a little looser like this. This is not really a valid Boolean condition, but let's just pretend it is. Okay, so this is saying coin value should be between 1 and 99. And the amount left should be between 0 and 99. So if these conditions are true, then the number is set to max number of coins. Okay, so number being a call by reference, you can think of this as an output. Yeah. Okay, so what we would do in this code is we would check the preconditions, assert that, and here is what we used to do in Csis 235. We use actual Boolean conditions like this. So we'd use this rather than this. They mean the same thing, but you remember in Csis 235, preconditions should be a little bit more formal, like this. This is what you would put in. And then you AND it with this other thing. That is the amount left. And so if the preconditions are satisfied, you go on and compute something. If they are not satisfied, then this whole thing, this is a huge one. I would have used a smaller, I should have used a smaller example. This whole thing is false, then the program stops right here. So Java programmers, you see something similar. You use asserts. And if the condition is false, it throws an assertion error, which you can catch in the calling method. So this asserts are useful for debugging. It stops execution so that problems in your program can be investigated. You can turn assertions on and off, and the way you do that is with this pound define and debug. So add this pound define before the pound include line for Cassert, and this turns off assertions. Java, it was a little similar. You use a compiler switch or a compiler flag -EA to enable assertions. By default, they are disabled. So in C++, what you want to do for the similar behavior is to always have this, and then maybe remove it if you want to turn on asserts. Okay.